Hi guys, let's start our quadratic functions first unit here, and let's look at the first lesson, simplifying and factoring polynomial review. So the first questions here say expand and simplify. So expand is just another way of saying distribute or multiply. All of those mean the same thing as expand, and then simplifying simply means to collect our like terms. So I'm just going to choose my favorite color, blue, here. And because I've got a 3x times, those brackets mean multiply, I have to multiply 3x times everything inside the bracket. So I'm going to distribute. And because this is an expression and not an equal sign, there's no equal sign in this expression, I'm just going to put an equals down below, which basically means that the next line is equal to that which is above. So 3x times 2x is 6x squared. A 3x times a negative 8y is minus or negative 24xy. And a 3x times 7 is a positive 21x. And then, of course, we're going to distribute here. Let's do another color here for this next section here. And we've got a negative 5x. Keep in mind that that's a negative. That's a negative 5x times a 4x, which is a negative, 20x squared. And negative times a negative 6y is a positive 30xy. And, of course, a negative times a negative is a positive 5x. Negative 5x times negative 1 is positive 5x. Now we're going to combine those like terms. So let's use another final color. I've got a 6x squared and a negative 20x squared, so that's a negative 14x squared. And we've got a negative 24xy and a positive 30xy, so that's a positive 6xy. And I've got a 21x plus a 5x, so that's a plus 26x. So there's our simplified version there. Now, this next one, you can't just multiply straight across because that's just like saying here, and I'm just going to take this. Let's just take this and shrink this down a little bit. Oops, sorry guys. I'm going to take this and just shrink it a little bit. Okay, or move it over just so we're not going into the other side here. When I look here, remember bed mass means we do our brackets and then our exponents and our division, multiplication, addition, and subtraction, bed mass. So before I multiply this 7a times the 3a minus 8, I have to do my exponent. Notice there's a little exponent there. So we're going to expand this. So this is 7a times 3a minus 8 times 3a minus 8. So I can... There's a couple of shortcuts you can do, but this would be sort of the longer version. The shortcut would be to square the first term, double the product, and square the last in here, because of course that's a binomial squared. But we can just do it this way as well. I could multiply 7a times 3a minus 8, or I can save the 7a till last, and I can FOIL this part here. So let's FOIL first, outer, inner, last. And let's just hang on to the 7a for now. And we're going to go 3a times 3a, so that's 9a squared. 3a times a minus 8 is a minus 24a. And then we get another negative 24a because negative 8 times 3a. And then we get negative times negative, that's positive 8 times 8, 64. And now I'm going to simplify a little bit. 9a squared minus 48a plus 64, okay? I dropped 24 a's and I dropped 24 more. I've dropped 48 a's. Now I'm going to distribute through my 7a, and I get, what's that, 63a cubed, and then 48 times 7. I'm going to need my calculator for that one, which I apologize. I don't have that at the ready here. Oops. Anyway, we'll have to do that one in a second. Oh, and 64 times 7. Oh, Mr. Schwartz needs to just do a quick... I'm literally grabbing my calculator as we speak because I don't want to spend the time. I should. I was going to say it's close to 350 because, right, 350, 48, 50 times 7 is 350 minus 14. Of course, that's 336. I guess we could have done that in our heads, right? So negative 336a squared, and then 64 times 7 is a positive 448. Okay, so There we are, just with some simple kind of expanding from grade 10. Then we want to look at GCF factoring. GCF is our greatest common factor. So we always, grade 10, we talked about this a little bit before we finished the course there, before we went into the stuff. We did get through factoring, most of us in class. So probably your teachers or I, if I was your teacher, said always, we want to do our greatest common factor first, kind of take that out. Okay, factoring means to write a polynomial as the product of polynomials. It's kind of like dividing. It's the opposite of expanding or multiplying. So GCF, let's take out the GCF for these ones down here. So I want to look at the coefficients, the numbers first, and then I want to look at the variables. So if I look at 64 and 16, my GCF there is actually 16. I can take 16 divided by 16, and I can do 64 divided by 16. So we need to be pretty good at division in order to do math 20, okay? And so 16 is our, and we're gonna divide by 16. That's basically what we're doing. I don't always write that down, but when I take out a 16, I'm just going to basically do 64 divided by 16, which is of course 4, okay? And then I wanna look at the, oops, and I just wanna do this too, sorry. I also wanna look at the, variables. So what is the biggest amount of variable that we can take out of each term? So if I look at this here, I've got an a squared and an a cubed. So the largest amount of variables we can take out of there would be an a squared. And then we've got a b squared and a b squared. So we can take b squared out of both of those. So our greatest common factor is in fact 16a squared b squared. And when we divide those out, when we divide out by a squared, b squared, our first term we're left with 4, just simply 4, because a squared, excuse me, a squared, b squared divided by a squared, b squared is simply 1. And we are left here with a negative 1a, okay? A negative 1a, or just minus a. Alrighty, let's look at the next one. If we look at our x's, y's, and z's, there's no common variable term there, I can see right off. But what is the greatest common factor that will go into 144, 108, and 60? I believe that's 12. What's 108 divided by 12? I think that's 9. Yes, it is. So 12 is our GCF. So 12 goes into 144. 12 times, whoops, I started writing 144. So that's 12x squared minus 9y squared minus 5z squared, okay? We're dividing everything through by 12. And then we get to factoring trinomials. So there's a few ways that we can do this, but the first thing, again, whenever I see a number in front, remember, trinomials, these are in the form of ax squared plus bx plus c, which is what is right here. When I see a polynomial in that form, the first thing I always want to do is try to factor out the a value, if possible, okay? If possible. Okay, now, down here we have a few examples where we don't have an a value, so these will be easier. So what I want to do here is we look at we have the product sum rule. So I want to look at numbers that give me a product of negative 20 and a sum of 1. Because basically we're going backwards. Instead of distributing two binomials that gave us this trinomial, we're going backwards and saying what were the factors, what numbers did I multiply to give me negative 20? And I added up to give me a positive 1y. So sometimes we say, let's make a chart. And I will put negative 20 here, okay? And I want what numbers will multiply to give me 20. Really, I don't have to look at the negative sign to start, but I can multiply 1 times 20, or 2 times 10, or 4 times 5. Any of those will give me a product of 20. So I need to be able to find my factors really quickly, okay? And then I say to myself, well, which of these would add up to a positive 1? 1 and 20 have a difference of 19, right? 19 is the difference there, plus or minus. Here, this would be a plus or minus 8, and here, this would be a plus or minus 1. So these are the right answers right here. This is the right choice, 4 and 5. In order to get that, I would need a positive 4 and a negative 5. So I've got a y plus 4 and y minus 5. So those are our factors there that will give us, and if we wanted to do a check, those would give us, let's just see here, we would do a check if we want. You don't have to, but we can even do almost like a mental check. You get a y squared minus 5y plus 4y minus 20. And of course, these two guys here simplify to y squared minus y minus 20. Okay, so there's like a little check, and you can sort of do that in your head if you are wanting to double check to see that you've got the correct answers, okay? Another method of doing this is to use the box method, which I sometimes recommend because it's sort of a good way of organizing things. Up to you. You definitely can choose any method that you prefer. I do like the box as well, and I do try to at least give it as an option in grade 10. So what we do is we create a little box, and then we fill in our terms. So we've got a y squared and a negative 20 here. And then we still have to figure out what numbers would multiply. So I would go negative 5y and positive 4y here. So we still have to come up with these two factors. And then we just simply, what we do here is let me just shrink this down a little tiny bit. What we do here is then we factor by grouping, and we just write our factors here. So what I would do here is I would say, looking vertically, I'd say what's my greatest common factor here? My greatest common factor here is y, and my greatest common factor here, if this is a negative, this term is going to be negative, so I've got a negative 5 is common there, right? Negative 5y and negative 20, negative 5 can come out of both of those. So therefore, one of my factors is, I'll just erase this little arrow here, one of my factors is y minus 5. And then when we look horizontally here, I've got a y squared and a negative 5y. Y is a common factor. And then 4 and negative 20. Well, this is a positive 4, so this is a plus, and 4 is common to both 4 and 20. So then again, we get y plus 4. So those are our two factors. Just another way of organizing if you don't like to just simply put them out like this. It just, I think, helps a little bit with the factoring, because we kind of have to factor later on when we do trinomials where there is an a value. That's a helpful strategy, I think. Okay, so the next one here, again, when there's only a value in front of a 1, it's kind of straightforward. We're looking at a product of 28 and a sum of 11. Probably most of you can look at that and just say that's 7 times 4. But if not, you can write those out and you can go 1 and 28, right? We're looking for a product of 28. And I would write out my factors 2 and 14 and, excuse me, 4 and 7. So I go m plus 4 and m plus 7, okay? We don't have to decompose every single one. If it's a 1 in front, we don't have to use decomp. But when we get to the next one, we've got a 5, a 40, and a 60. So here, my greatest common factor, remember we want to do GCF first. Always check for GCF. The reason I didn't worry about it here is because this was just a 1. So there was no GCF, right? No greatest common factor. But here, our GCF is 5. So I go 5x squared minus 8x plus 12. So I factored out a 5. And now I still need to factor by inspection because this is a 1. So I need a product of 12 that adds up to negative 8. So I'm going to write down 12. And so what can multiply to give me 12? Well, that's 1 and 12. 2 and 6, excuse me, 3 and 4. And of course, the ones that can add up to 8 here would be 2 and 6, and this needs to be a positive 12, and I need a negative 8, so that's negative 2 and negative 6. So when we rewrite this, we get a final answer of 5x minus 2, x minus 6. Excuse me. Now, if I look at question D looks kind of wonky because there's some brackets. Basically what we want to do is I want to take this, m plus n, and I'm just going to say, let's let x equal m plus n. So let's not deal with m plus n. Let's just call this x squared minus 2x minus 3. I'm using substitution, okay? Because that m plus n is just sort of extraneous. It's there to kind of make it look more difficult, but there's a trick. We can just, let's sub out the m plus n and make it x squared minus 2x minus 3. And now I want to factor the same way. I want a product of negative 3 that adds up to negative 2. And of course, 1 and 3 is the only thing I can multiply to give me negative 3 or 3. And so this one will be positive, and this one here would be a negative. So when we factor this, what we get here is we get x plus 1 rather, and x minus 3. But now I have to go back and write my final solution with this guy here. So where I have an x, I'm going to sub back in an m plus n. So we get m plus n plus 1 and m plus n minus 3. Okay? So that's a good start for now for those types. And now the next one says find 3 values of k such that the following trinomial can be factored over the integers x squared plus kx minus 12. So here, what numbers could go in there for k? Well, if I'm looking for a product of negative 12, what numbers multiply to give me negative 12? Well, 1 and 12, 2 and 6. Let's just squunch those in a bit more. 1 and 12, 2 and 6, and 3 and 4. So of course, if I need a product of negative 12, one of these terms has to be negative. Doesn't matter which one. So this could be negative, this could be negative, this could be negative, or the opposite ones. So therefore, this could be plus or minus, and then the other one would have to be plus or minus, right? So one of them would have to be positive and one would have to be negative to give those values. If this was a positive 1 and a negative 12, then we would have a value here. Our sum would be either positive or negative 11, right? Positive 1 and negative 12 would be negative 11, negative 1 and positive 12 would be positive 11. So again, here we would get positive or negative 4, right? Positive 2 minus 6 would give me negative 4, negative 2 plus 6 would give me positive 4. So, and then the difference here, plus or minus 1. So the values of k, we instead of having 3, we actually have 6. K could be equal to plus or minus 11, plus or minus 4, and plus or minus 1. Okay, sometimes the greatest common factor cannot be factored out first. In this case, we use decomposition, because in this case, our a value is not equal to 1. So let's just cruise on down and we'll do a couple of decomposition questions. I'm just looking down here. There's quite a few. Probably not going to do every single one of these, but we'll do a couple, okay? I'm just going to pause there and we'll finish this. Well, let me give you one and then I'll get you guys to try B, okay? And maybe C. So with this case, we can't factor out a 4 because 4 doesn't go into 5 and 4 doesn't go into 6. So what we want to do is we want to look at these terms here. And we're basically, it's kind of the idea behind it is we're setting up a proportion. We never usually explain that, but it's fine. The process here is that we're looking for a product of negative 24 with a sum of negative 5. So with this value here, we have to multiply these. So my product here is a negative 24. And again, I still look at those factors. We say, what do we multiply to give us 24? Well, what do we multiply? We get 1 and 24, 2 and 12, 3 and 8, 4 and 6. And which of those could add up to a 5? These two here. Okay, so now I've got to break this down. Because there's a 4 in front, we need to do this decomposition. We're going to break these middle terms down into, well, what do we break these down into? Let's just erase some of this for a second. We're going to break this down into a 3 and an 8. But now which one has to be negative? We know that we need a negative 5, so the bigger number has to be negative. So this is going to be a negative 8x plus 3x. So remember, when we decompose, we're just breaking it down into another form. If we were to simplify negative 8x and 3x, we would still get negative 5. And then we've got our negative 6, that just gets carried down, and the 4x squared gets carried down. So there's the start. Now we want to factor by grouping. We look at the first two terms. right? We're going to look at these first two terms, and then we look at the last two terms. And we go 4x squared minus 8x. The common factor here is 4x. And we're left with an x minus 2. And we look at the next two terms, and our common factor here is a 3. And we're left with an x minus 2. And then when I look at both of these guys, we say, well, what's common here? This is common, and this is common. So we're going to get a final answer of x minus 2 times 4x plus 3, because that's what's left over here, right? When we factor an x minus 2 out of both of these terms, we're left with a 4x plus 3. So there we are with that one. If I look at question B, let's just give a start here. I know the GCF is 3, so we're going to take a 3 out of here, and we're left with a 2x squared minus 3x plus 1. And again, this is an a value other than 1, so I need to multiply that through. Okay, and we need a product of 2. Okay, our product is equal to 2 with a sum of negative 3. So I'm going to give you guys a second to try that one, and maybe try this one, even just try the first steps. Okay, so let's just pause the video. I'll pause the video, and I want you guys to try those couple, B and C. Okay? Okay, hopefully you had a chance to try question B and question C. Question B here, we end up with a 3x minus 1 times 2x minus 1, and question C, we end up with an x plus 5 times 3, y plus 5 times 3y minus 2. Now, one thing I want to note just about question B is sometimes students get a little bit mixed up on the factoring here with all the signs. This row here in question B would get a little tricky. So one thing you can do, instead of just using the straight decomp method where we're decomposing that middle term, is we can still use the same idea, but we can also do something called the box method, which I like it a lot. Not everyone likes to use it, but I do think that it's kind of helpful. It alleviates mistakes, I would say. So if we were to rewrite these terms, the 2x squared, so we still have to rewrite the terms that stay, the 1 and the 2x squared. And then we still have to come up with the other factors of negative 3 here that would add up, factors of 2 that would add up to negative 3. So those, of course, would be negative 2x. Let's just write that in another color here. That's our negative 2x and our negative 1x, or negative x. And then what we do is we just factor horizontally and vertically. So I think that it allows for us to see the factors, and the factoring becomes a little bit easier. If I see the 2x squared and the negative 1x, the only thing common there is the x. The negative, because it is not in the first box, won't come out. So for example, this is going to be an x. And then when I look down this horizontal row, when there's a negative here, I'm going to factor it out. So that's going to be a negative. And there's nothing common between negative 2x and 1, so my common factor is simply a negative 1. And when I look at the vertical factors here, 2x squared and negative 2x, of course 2x is common, but the negative being over here doesn't come out. So this, on this first term, okay, it only comes out here, and this negative here is going to come out here. So over here on the top column here, we get a 2x, and then a negative 1x and a 1, we take out a negative 1. So there we can see our two factors are 2x minus 1, which is the same here, and x minus 1, which is the same as here. So sometimes I think that the box method just allows for fewer mistakes with the factoring here, from here to here. Okay, something to think about. So let's look at question D. It says, for which integral value of k can the trinomial 5x squared plus kx minus 6 be factored? Excuse me. all this talking is giving me a tickle in my throat. So here we're looking at what factors of negative 30 will give us a value of k. So we're looking for what are the factors of negative 30, because 5 times negative 6 is negative 30. Okay, and therefore, if we've got that negative 30, what numbers give us negative 30? Well, we can have 1 and 30, 2 and 15, 3 and 5, 3 and 10, sorry, and 5 and 6. Those are our 4 sets of factors of 30. So once we know those, what we can then do is we know that one of them would have to be positive and one of them would have to be negative, plus or minus or plus or minus. One's going to be positive and one's going to be negative. So if the 5 were negative, the 6 would be positive, or vice versa. And then when I look at that, basically means if one's positive and one's negative and we're adding them, they're going to be a difference. Okay, it's going to be a difference. So positive 30 minus 1 is going to be 29, or a positive 1 minus 30 would be negative 29. So our k value here, our sums, would be, if we just go through and do the math here, plus or minus 29, plus or minus 13, plus or minus 7, and plus or minus 1. So k would be those 4 values, plus or minus 29, plus or minus 13, plus or minus 7, or plus or minus 1. Those are the values that could fit in there and make this a factorable question. Okay? I don't want to do every single one here. This one here, if I were assigning you g, what I would do here, because this is kind of a wonky order, I would rewrite this in the ax squared plus bx plus c order. So that would give me a negative 15d squared plus 14d plus 8. And then just to make things easier, I don't like this negative here, so I would factor out the negative. And then I would factor 15d squared minus 14d minus 8. Okay, minus 8. Oops. Let's just see here. Subtract 8. Okay, and then I would be looking at factors of, I want, I guess, a product of negative 120 with the sum of negative 14. And I think if we go through, it's 20 times 6 is 120, and that will add up to negative 14. And the only reason I know that is because we just did that question the other day, so I just did that really quickly. If not, you have to go through and figure out the factors, right? 1 and 120, 2 and 60, 3 and 40, 4 and 30, etc. But once you go through and write them out, you can always find them pretty quickly. So we would rewrite this, and of course this needs an equal sign, and we go negative 15d squared minus 20d plus 6d minus 8. And then let's factor out here 15 and 20. Looks like a common factor would be a 5, right? 5 would be our numerical common factor, and a d. So then we get a 3d minus 4. And then with the 6d minus 8, we can take out a 2. And again, we get a 3d minus 4. And our final factors are 3d minus 4 times 5d plus 2. Okay? Now the last type of factoring I think that we should look at would be a difference of squares. And the thing with the difference of squares is you can pretty quickly identify a difference of squares. Okay, this just talks about different kinds of factoring. We've looked at x squared plus bx plus c, where our a value is equal to 1. We've looked at ax squared plus bx plus c, where we have to use a decomp. Okay, and the only other thing, perfect squares we can look at later, but I think a difference of squares is one of the ones that is quite common, that we sometimes look at and are like, what's going on? If I were to factor or multiply through x plus y times x minus y, when we multiply that through, what we get is we get an x squared, a minus xy, a plus xy, and a minus y squared. And what happens to those middle terms, as you can probably recall from Math 10, is that those two guys cancel, and you're left with x squared minus y squared. So to go backwards, we need to end up putting this binomial into two binomial factors. So how to do that? How to recognize the pattern? What we see is we say, this is basically kind of almost like the formula. Okay, if it's a perfect square, it's the square root of x squared, which is x,
and x. It's the square root of y squared, which is y and y. And one of these terms inside the, one of the signs is a positive in the binomial, and one of the binomials has a negative. So for example, down here, when I recognize, hey, this is x squared minus 9, is that if it's a binomial, by the way, the only kind of factoring we can do is either a GCF or a difference of squares. Okay, so as soon as I see a binomial, I'm going to look for a GCF, and I'm going to look for a difference of squares. So I look at this first term, and I say, this first x squared, and I say, is that a perfect square? Well, of course it is, because the square root of x squared is x, and I rewrite that as an x and an x. And then I look at this negative 9 here. I say, well, is that a perfect square? Well, 9 in itself is a perfect square, the square root of which is 3 and 3. And then one of these is going to be a positive and one's going to be a negative. And if I wanted to do a little check, right, if we wanted to do a little check and multiply those through, we get x squared minus 3x plus 3x minus 9, and we end up with our x squared minus 9. Okay? So I know that I've done things correctly there. Another way to sometimes think about the perfect square trinomial is, or sorry, the binomial rather, is to think of it like this. As we say x squared plus 0x, we have 0x in our trinomial. We can think of it back to that form. And then we would say, what are the factors of negative 9 that add up to 0? And it's plus and minus 3, right? X plus 3, x minus 3. So if we think of it like that, that's just another way it still works out for us. If we look at question B, again, is this a perfect square factor? And is this a perfect square? For sure they are, because the square root of 16x squared is 4x, and square root of 1 is 1. So I go 4x plus 1, 4x minus 1. And there's my factoring there. Question C is similar to question prior, where instead of the a plus 7 all squared, I want to just let x equal a plus 7. And this just lets us put this back into a form that looks a little bit less frightening. Okay, so we've got an x squared minus b squared, which is x minus b, x plus b, and then of course let's sub this back in now that we've factored it, and we've got an a plus 7 minus b and an a plus 7 plus b. Okay, so I would suggest you go ahead and try to do some of the questions in the assignment. I guess we could look at one perfect squares example. And when we see a perfect square trinomial, we can always use decomposition to solve something like this question here, but when we look at a perfect square trinomial, we recognize there's a pattern such that the first term, a squared, and the last term is a perfect square, like b squared, and the middle term is made up of 2 times the square root of a squared and the square root of b squared, which is 2ab. So for example, if we look at this first question here, if I factor this using decomp, I need a product of 100, right? 4 times 25 is 100. We would need a product of 100 with a sum of 20. So probably some of you can think right away that that's 10 and 10. We could decompose this. Okay, let's do that. 10m and 10m. Carrying down our first term, carrying out our last term. So we've got the 4m squared and the plus 25 here. And when we factor by decomp, our first 2 terms and our second 2 terms, we can take a 2m out of here, and we get an m plus 5, and we can take a 5 out of the second 2, and we get a 2m, oh, and this should have been a 2m, sorry, 2m plus 5. As soon as I noticed those weren't the same, I knew I did something wrong. So we end up here with a 2m plus 5 times 2m plus 5, right? Note that these are the same. And we could rewrite that. We can also write that as 2m plus 5 all squared. So what we can do to recognize a perfect square, though, is another thing, is we can just say, well, I know that my factor is going to be the same if it's of this form. Is this a perfect square? Yes. The square root of 4m squared is 2m. Okay? Is the 25 a perfect square? Yes. The perfect square and the square root of 25 is 5. Is, and as a little check, I should check, is 2m times 5 times 2 equal to 20m? Well, yes, it is. So therefore I know that this is a perfect square, and it follows the formula, so the pattern. So I can see right away that 2m plus 5 all squared is my answer. It's just a shortcut if you recognize the sort of pattern of the trinomial. So for example, if I look at this question, factoring using my shortcut, the formula-ish if you want to call it, what's the square root of 81a squared? That's 9a. What's the square root of 16? Well, that's 4. And is 9a times 4 times 2 equal to 72a? 9 times 4, 36 times 2 is 72. Sure it is. Now I need a negative. So I need a negative here. So one of these has to be a negative. And the one that has to be a negative is the negative has to be in the middle. Because we're going to get a negative 4 squared, which gives us 16 when we square that. So it's just a shortcut. You can always decompose those. It just, to decomp 81 times 16 would be a tricky question, right? You're working with pretty big numbers, so if you can recognize the pattern, that is great. And the last type of factoring that we might have to do, which we've already really been doing, is grouping, factoring by grouping, where you look at the first two terms, which we have to do that to do decomposition anyway. We look at the first two terms and we take out what's common. We can see that there's a 2x common to both of those, and we're left with an x plus y. And then we of course look at the second or the last two terms, and we can see that I can take a negative 3 out of both of those terms and a y, and we're also left with a y plus x here. Okay, when we factor this out, we get a y, and a negative 3xy divided by negative 3y would be a positive x. So even though these are in different order, x plus y and y plus x, those are the same things. So we just rewrite that as x plus y times 2x minus 3y. Okay, there's our what we're left with there. So I've given an assignment here. If I look at the assignment booklet, I would assume that we should do pretty much, let's just take a look here quickly. I would assign most of these questions, probably number 1, B, D, 2, A, C, D, E. I would try that one. Number 3, even if you did the odds, okay, if you did the odds. And if you do the perfect squares, you could quickly do a couple of these, and maybe do a couple of these. Okay, and then down below, factor completely. I think this is a little bit of a mix. You could try some of these more challenging ones as well, if you would like. But probably at least do 1 to 8 odds. Okay, and I should probably write that down here. Number 1 to 8 odds to start. Okay, thank you and good luck.